حضراتكم. اسمحوا لي يعني أقدم أستاذ الدكتور أستاذ مساعد دكتورة سمر عبد الحفيظ in Epidemiology Department، صح كده، في المعهد العالي للصحة العامة جامعة اسكندرية. إن شاء الله اتكلمنا عن Correlation و Regression Analysis. أنا متأكدة إن إحنا يعني هنستمتع وهنستفيد استفادة جامدة جدا. أستاذن حضرتك يعني ساعة ماكسيمم من دلوقتي أو من 50 ل 60 دقيقة كده عشان وقت حضرتك أكون شاكرة يعني.
طيب تمام، ميرسي. هم قايلين لي ساعة ونص بس. أوكي،
ساعة ونص؟
مفيش
ساعة ونص بالدسكشن، ما هو بالدسكشن.
ماشي أوكي، لا ماشي أوكي.
حضرتك
هو
إحنا مع حضرتك للصبح، ما تقلقيش، اتفضلي.
لا مفيش حاجة.
اتفضلي.
ميرسي جدا على أولا ميرسي جدا دكتورة منال، ميرسي جدا دكتور تامر على الانفيتيشن، وده شرف ليا إن أنا أكون مع حضراتكم يعني النهاردة. وأتمنى يعني إن أنا ما أكونش ضيف تقيل، وإن المحاضرة إن شاء الله يبقى فيها إفادة بإذن الله. أنا هاحاول. هو دكتور تامر قال لي إن يعني ممكن تبقى عربي، بس أنا مش عارفة هل كل الناس اللي موجودة حاليًا. أنا شايفة إن يعني في participants 73
ما شاء الله.
يعني مش عارفة لو في حد مش هيبقى فاهم، يعني هو ممكن يوقفني في أي لحظة.
يعني
أنا
هتبقى ميكس يعني، أعتقد كده وكده يعني.
خلاص إن شاء الله.
إن شاء الله.
طيب بسم الله.
اتفضلي.
هو زي ما إحنا
هو الصوت مش واضح بس يا دكتورة.
صوتي أنا اللي مش واضح؟
هو بالنسبة لنا واضح جدا، يمكن عيب نت أو حاجة،
لا
لأن
الصوت
أنا عندي
واطي جدا.
حضرتك يا دكتور تامر واضح؟
واضح.
أنا
الصوت واضح عندي.
بالنسبة لي واضح.
ممكن يكون الصوت عند حضرتك صوت واضح
في
عندنا.
مشكلة في النت عند حضرتك احتمال
ممكن
بقى.
حضرتك ترفعي صوت الكمبيوتر او الايباد او الموبايل، لان
ممكن
احنا الصوت واضح عندنا جدا يعني.
ممكن حضرتك تعملي سبيكر.
خلاص يا حبيبي. خلاص حليت المشكلة من عندي.
شكرا، اتفضلي.
طيب هو النهارده زي ما حضرتك أشرتي، إن شاء الله أنا هاحاول أدي يعني overview about the correlation and the regression analysis, not from a statistical point of view but from a methodological point of view. بمعنى تاني إن أنا مش هادخل in details how to do it، بس أنا I will explain when we need to do it. ببساطة the correlation and the regression analysis, the simplest key question we want to answer from this analysis is what's the relationship between different factors or variables. We have different terms that we use to identify the relationship between different factors: the correlation, the association, the prediction, regression, and causation. And all these terms refer to a relationship. So what are the differences between these terms? When I prefer the interaction. So if someone wants to answer or to interact with me, I like that. Yeah. Could someone tell me in brief what's the difference between these terms?
We may use the option of raise hand please عشان ننظم بس عملية المشاركة. فريز هاند هتلاقيها موجودة، و just raise hand and we are going to يعني give the mic for the one who raised their hands.
Okay. So it seems no one raises his hand. Okay, someone raises his hand too.
دكتورة علياء اتفضلي.
أنا ممكن أقول difference between correlation and causation. correlation is different from causation. يعني causation ممكن يكون الحاجة يعني مسببة لحاجة، لكن correlation يعني الاثنين ممكن يكونوا بيزيدوا مع بعض أو بيقلوا مع بعض، لكن مش سبب له.
طيب تمام. يعني to a great extent this is correct. So let's put in our mind from the beginning that correlation does not imply causation, and we will go and explain this in details through our presentation. But just put in your mind that causation is not equal to correlation. And
دكتورة سلوى برضو raised her hand.
I'm sorry. So if Dr. Salwa wants to add something.
prediction the result in after the يعني in the future يعني prediction يعني اللاين اللي هو اللي احنا بنعمله احنا ممكن نستنتج منه او المعادله والايكويشن اللي احنا بنعملها في الريجريشن بتعمل لنا ممكن تدينا الايه البريدكشن للريزلت in the future.
تمام اوكي صح from a statistical point of view. To some extent this is not fully correct from a methodological point of view, what I'm going to explain through the presentation. So we have 2 points that we need to put in our minds through all the presentation. Why correlation cannot imply causation, and what's the difference between the regression and the prediction from the statistician point of view and from the methodologist's point of view. تمام? Okay. So to understand the relationship between 2 variables, at first I need to see how these variables are interacting to each other. And to do that, I need to graphically present the relationship between the 2 variables in the form of what's called the scatter plot. So the scatter plot is the way to visualize the relationship between 2 different variables. And all these steps that we are going to explain, all software programs can do it starting from the Excel. So we will not go through which program can do this statistical analysis. Based on the scatter plot, we have different forms of the relationship. So the relationship between X and Y, or the 2 variables, either to be a linear relationship, or there is no relationship at all, or there is a certain form of the relationship which takes the form of a non-linear, or what's called the curvy linear. Okay? So, till this step, I just understand what's the visual relationship between the 2 forms. But is it enough to have this and stop at this point? No, because I need to answer more questions to understand deeply the relationship between the 2 variables. So what are the questions I need to answer more? I will go to the correlation to answer these 2 questions. The first is the strength, and the second is the direction of the relationship between the 2 variables. So now I'm speaking about only 2 variables, X and Y. And I didn't determine which one is the independent and which one is the dependent. I have 2 variables, X and Y variables, and I want to know whether there is a relationship between the 2 variables or not. At first, I see this relationship in the form of a scatter plot. I determined the form of this relationship, whether it's a linear, non-linear, or there is no relationship. Then I want to understand the strength and direction of the relationship. By the graphical presentation, I cannot answer these questions, the strength and direction. I need to answer these questions by doing what's called the correlation analysis. What are the types of the correlation analysis we have? We have the 2 most common forms of the correlation, something called the Pearson correlation coefficient, and the other one is called the Spearman correlation coefficient. What is the difference between both? Could someone tell me what are the differences between the Pearson and Spearman?
Pearson for the quantitative and the other for qualitative.
And that's it?
If one of them, the independent is qualitative.
Okay. So to use the Pearson correlation, which is the most common form, I need certain assumptions to use it. At first, that both variables are normally distributed, and there is a linear relationship between these 2 variables, and I don't have skewed data, so there is no outliers, and the variables are continuous. To use the Spearman correlation, I need to have one or both variables to be not normally distributed or skewed, or one of the variables is ordinal and the other variable is continuous, or both variables are not normally distributed. So let's have examples. If I want to test the correlation between the systolic and diastolic blood pressures, and both variables are normally distributed, which type of the correlation could I use?
A person.
Person correlation.
If I want to test the relationship between the age and serum creatinine, and the age is not normally distributed, which type of the correlation could I use?
Spearman correlation.
If I want to test the relationship between the cholesterol level and the risk of cardiovascular disease, what is the type of the correlation could I use?
Person correlation.
Spearman as well.
Data
Spearman.
Spearman.
I want to test the relation between a cholesterol and the other variable is the risk of having cardiovascular disease.
The Spearman correlation.
Yes, exactly, the Spearman correlation. So
Because
now
one of them is ordinal.
Yeah, exactly. So because one of them is a categorical variable, so I cannot use the Pearson correlation. So this is the classical way of classifying the types of the correlation. Some references mention that I can use the Pearson correlation if I have at least one of the variables is normally distributed. So if I have two variables and both are continuous variables, one of them is normally distributed and the other one is not normally distributed, some authors or some literature allow me to use the Pearson. But the classical is if both variables are normally distributed, I'm using the Pearson. If one of them is not normally distributed, I'm using the Spearman. But if you read this in one of the papers, it's not definitely wrong or it's not definitely correct. Okay. So how can I interpret the
دكتورة سمر.
Yes.
دكتور ابراهيم خربوش معلش رافع ايده من فتره، فاتفضل دكتور ابراهيم. يمكن
هو
في
أنا
عايز
شكرا دكتور تامر. اهلا دكتوره سمر. انا بس يعني طبعا كلامك يعني اورثودوكس سبيكينج هو صح، بس انت لما تحسبي الاثنين هتلاقيهم ايكوال.
In which scenario, دكتور إبراهيم؟
يعني لو حسبتي السبيرمن لاني كيس انت منشنت اند البيرسون هتلاقي النتيجه في الاخر واحده. الفروق تبقى ضئيله جدا.
ايوه بس which one؟
انا بعمل في كل الامثله اللي انت قلتيها. انت قلتي الفرق بين السبيرمن والبيرسون وانك بتستخدمي ده في كذا وده في كذا. لو حسبتي ده هنا وحسبتي ده هنا، مثال الايج مثلا والبلاد بريشر، وحسبتيه في البيرسون وحسبتيه في السبيرمن، النتيجه في الاخر بتطلع واحده. very close.
ايوه هتطلع very close بس it's not exactly the same، وهي عمره ما
الفرق بيبقى يعني ضئيل جدا يعني. انا معاكي كلام نظري صح جدا وانا بمشي عليه، بس براكتيكالي ما بيطلعش فرق
زي بعض. لو كان السامبل سايز صغيره بيطلع فرق، لكن لو كبيره بيطلع ما بيطلعش.
سبيرمان دايما بيستخدم اذا كانت السامبل اكتر من 30.
يعني دي ملاحظه بس عامه يعني. اوكي شكرا.
طيب how can I interpret the correlation coefficient? The correlation coefficient is the specific measure that quantifies the strength of the relationship between the two variables in the correlation analysis. The first thing that I should put in my mind is the correlation coefficient is unit-free, so I cannot put a unit for the correlation coefficient, and it usually ranges between -1 to +1. And the closer to -1 refers that this is a very strong negative linear relationship, while if it's closest to +1, it means that this is a strong positive linear relationship. And if I have the correlation coefficient closest to 0, it means that this relationship is weak. So based on this correlation coefficient, I have different forms of the correlation. Either it's a perfect positive correlation, so the correlation coefficient will equal to 1, or high positive correlation, so it's more or less close to 1, like 0.8, or a low positive correlation, so it's 0.3, it's still above the 0, but it's very far from the 1, or it's -0.3, which means that it's a low negative correlation, or it's minus 0.8, which means that it's a high negative correlation, or minus 1, which means it's a perfect negative correlation. So looking at the value of the correlation coefficient, I need to put in my mind two things, the sign and value. In the correlation coefficient, it's not that important to look at the significance rather than looking at the value of the correlation coefficient and the sign. Why the sign? Because it tells me about the direction of the relationship. Why the value? Because it tells me about the strength of the relationship. So this is how I have the output from any different statistical packages. And for the output, I need to look at the value of the correlation. In this case, it's 0.966, and then the significance. So how can I interpret this 0.966? What does it imply?
Significant, positive, strong correlation.
Yes,
Perfect.
it's a strong positive correlation, and it's also significant.
Near perfect.
Yeah, near perfect. And this is the output for the Spearman rule. And I have the value of 0.66, and the significance is 0.04. What does it mean?
0.04.
So this is the value of the correlation coefficient. It's 0.66.
Positive low. 0.03.
Significant, positive correlation.
Yeah, significant positive correlation. So let's take the relationship to a further step. Based on the correlation, I understand the relationship between the two variables, the x and y. But based on the correlation, could I understand to what extent one variable affects the other? Yes or no?
دكتوره سمر دكتوره دعاء رفع ايدها برضو.
دكتوره دعاء محمود رفع ايدها من مده.
اتفضلي. انا مش بشوف
لا
الناس اللي
اتفضلي. لا
بترفع
احنا نقول دكتوره دعاء محمود اتفضلي.
في مشكلة في الصوت.
على
في مشكلة في الصوت مش واضح.
على النوت اللي قبل دي.
افندم؟
كان كومنت على النوت اللي قبل دي لما حضرتك السؤالين بتوع الكورليشن، هل احنا لازم يعني نقول في الكومنت على الكورليشن ان هو لينير كورليشن، لانه اوريدي في انواع اخرى من الكورليشن، ففي الموستلي اللي احنا بنستخدمه غالبا بيبقى اللينير. فهل احنا يعني سؤال لحضرتك، هل احنا لازم ندخل اللينير يعني اقول significant linear positive weak او moderate او strong correlation between x and y؟
لا، مش لازم ان حضرتك to refer to the term linear، لان it's usually used, the term correlation is usually used to express a linear relationship between the x and y, and if the relationship is not linear, I'm going to different forms of the analysis, other forms of the analysis to interpret this relationship. So you don't have to report the term linear when you express the relationship by doing the Pearson or the Spearman.
طيب دكتوره معلش، دكتوره سمر في سؤال تاني من دكتوره شيماء جايز ريليتد برضه اللي حضرتك بتقوليه. دكتوره شيماء اتفضلي. دكتوره شيماء محمود.
دكتور هو في بوردر بين اللو والهاي، في رقم معين يعني اقول اقل منه يبقى لو اكتر منه هاي؟
في ناس بتعمل لها categorization اللي هي يعني في ناس بتحط categorization من 0.5 ل 0.6 low، من 0.6 ل 0.8 moderate، above 0.8 or 0.9 بتبقى high، بس يعني this is arbitrary cut off points.
تمام.
اتفضلي.
تمام، شكرا.
دكتورة معلش سؤال تاني.
اتفضلي.
السيجنيفيكانس او ان انا اعلق على انه في correlation between two variables، هل انا في الاول يعني هل انا بعلق على مجرد ان الار طلعت اعلى من 0.3 او 0.5 فاقول عليها انه في correlation، ولا المفروض ان انا بشوف السيجنيفيكانس الاول وبعدين ريبورت على قيمة واشارة الار؟
usually طب انت بتتكلمي على manuscript ولا بتتكلمي على رسالة؟
لا هو عموما يعني انه
عموما انت when it's not significant you will mention there is no correlation.
تمام.
Okay, when it's significant you will report it as there is a positive correlation or there is a negative correlation. When it's not significant you will not mention that there is a correlation as long as it's not significant.
تمام. هو انا
دكتور
السؤال انه بنبص على البروبابيلتي الاول تمام او البي فاليو الاول وبعدين بنريبورت على الار.
بتريبورت على الار. هو عمر ما انت هتطلع عندك الار القيمه بتاعتها عاليه والسيجنيفيكانس هيبقى مش يعني it will not be significant. يعني ما ينفع يعني عاده مش هتبقى
الار بيطلع لها قيمه، الار بيطلع لها قيمه حتى لو ويك.
ايوه ما انا عارفه ان الار بيطلع لها قيمه بس يعني استحاله تبقى الار مثلا 0.7 او 0.8 وتبقى البي مش significant.
يعني يا
لو السامبل سايز صغيره
بوينت كام؟ يعني من اول ما
لا ما فيش حاجه اسمها من 0 كام. انت you will look at the significance. if it's significant then you will report that there is a positive or negative correlation. ملهاش cut off point لان it's related to the sample size.
دكتوره سمر معلش انا ممكن عشان بس يعني ما الاسئله لو فتحناها مش هنخلص، فممكن نخلي الاسئله كلها اخر.
يا ريت.
تمام اوكي مفيش مشاكل.
معلش برضو هطلب من حضرتك يعني برضو don't ask question and يعني wait for answers. استرسلي في المحاضرة بتاعتك ويعتبر ان احنا جاوبنا في نهاية المحاضرة هنفتح الدسكشن بالكامل.
اوكي تمام.
عشان بس وقتنا وقت المحاضرة يعني.
اوكي.
دكتورة آية السباعي برضو معلش ناخد سؤالها لانها رافعة ايدها من بدري وبعد كده نوقف الأسئلة تاني لحد آخر المحاضرة.
تمام اوكي. اتفضلي يا دكتورة آية.
السلام عليكم. يعني معلش هو انا كنت هسأل سؤال في الاول بس حضرتك جاوبتي فيه حاجه وانا حاليا عايزه اسال. يعني انا الكونكلوجن كده انا هبص على البي فاليو وات از significant، هبص اشوف الفاليو بتاعه الار وات ايفر هي ايه، هقول بوزيتيف او نيجاتيف significant correlation. لو البي من الاول خالص نون significant خالص انا ما يهمنيش اي قيمه للار مش هقول عليها اي كومنت او هقول there is no correlation. صح كده؟
تمام صح كده.
الحاجة التانية ما ينفعش حد يجي يقول لي أنا الداتا دي كواليتيتيف وأنا عايزة أعمل كورليشن. مفيش كورليشن والديبندنت والاندبندنت الاتنين كواليتيتيف. صح يا دكتور؟
بتعملي سبيرمان لو عندك الكواليتيتيف فاريبلز بتعملي سبيرمان.
سواء ما يكونوا الاتنين الديبندنت والاندبندنت كواليتيتيف مش يعني كاتيجوريكال كمان حتى مش اوردينال.
بتعملي سبيرمان لو هما باينري. بتعملي حاجة تانية اسمها كاندل 2 لو هو أكتر من كاتيجوري في الديبندنت عندك.
تمام. كاندل 2 ده لو هو أكتر من يعني مش
ordinal variable more than 2 categories.
اللي هو لو كان عندي يعني مش binary ولا ordinal.
You could search for that but you can at least you can do correlation if the dependent and the independent variables are categorical. You can do it.
Okay. Spearman. like non-parametric data نعمل Spearman.
بالضبط.
تمام شكرا.
تمام. So back to
معلش هوقف حضرتك تاني. هل الشاشة ظاهرة عند الكل؟ لأن في بعض الحاضرين بيقولوا الشاشة مش ظاهرة عندهم، ففي حد عنده الشاشة مش ظاهرة؟
الشاشة ظاهرة والصوت واضح.
لا
ظاهرة. طيب تمام.
لا ظاهرة والصوت كويس.
طب اتفضلي حضرتك دكتورة سمر مش هنقاطعك تاني لحد آخر المحاضرة.
Okay. So back to the relationship. The correlation answers the direction and the strength of the two variables. If I want to answer the question of what's the extent one variable could affect the other, which type of the analysis I should use? I should use what's called the regression analysis. So what's the regression? And why regression and not correlation? As we mentioned that the correlation describes the strength of the relationship where there is no sufficient knowledge to identify which of the two is responsible for the variability in the other variable, or when this information is irrelevant to the question being asked. What does it mean? It means that when I do the correlation, the x and y, the relationship between x and y will exactly equal the relationship between y and x. So if I put in the program the dependent and independent variables in the reverse form or in the reverse order, I will have the same value of the correlation coefficient and the same value for the p. So if I want to test the relationship between the systolic blood pressure and the serum creatinine, and now I'm doing the correlation analysis, I will put the systolic and the serum creatinine as the two variables, and then I will calculate the correlation coefficient. What I get from doing this analysis is exactly the same if I put in the program the serum creatinine at the beginning and then the systolic blood pressure. But
ممكن تاني يا دكتورة لو سمحتي؟
أفندم؟
ممكن تاني من فضلك لأن كان في مشكلة في الصوت. ممكن الجزء اللي فات ده تاني من فضلك؟
The correlation analysis cannot tell me
دكتور
which
هو في شاشة يعني للمحاضرة، في صورة للمحاضرة مش معمول
ايوه
لها شير.
موجودة، ايوه
موجودة؟ دي أنا مش لاقياها خالص.
I shared the screen, it's already shared.
أنا شايفة صورة حضرتك بس، لكن
لا
السكرين
لا
نفسها لا.
في سلايد باينة اهي. Why regression and not correlation.
أنا مش عندي.
اتفضلي يا دكتورة سما.
So in doing the correlation, and I have two variables like what I mentioned, the serum creatinine and the systolic blood pressure. لو أنا تعاملت مع التو variables دول وأنا مش عارفة مين فيهم الديبندنت ومين فيهم الاندبندنت، وحطيت في البروجرام بتاعي أو في السوفت وير بروجرام بتاعي الاثنين عكس بعض، يعني مرة حطيت please test for me the correlation between the serum creatinine and systolic blood pressure, and in the other scenario please test for me the correlation between the systolic blood pressure and the serum creatinine, I will get the same value for the correlation coefficient and the same p-value. لكن دلوقتي أنا am assuming based on the literature that the systolic blood pressure is affecting the serum creatinine level. So now I have in my mind that the systolic blood pressure is the independent variable and the serum creatinine is the dependent variable. So the systolic blood pressure could affect the serum creatinine. How can I test to what extent the increase in the systolic blood pressure will increase the serum creatinine? I cannot answer this question by doing the correlation analysis because, as we mentioned before, the correlation analysis will answer the strength and direction, but it will not answer to what extent the increase in the systolic blood pressure will increase the serum creatinine. To what extent, if I have 1 unit higher of the systolic blood pressure, I will get to what extent higher increase in the serum creatinine level. And to do this, I need to do the regression analysis. So the regression analysis is used to predict the value of the dependent variable based on at least one independent variable. يبقى دلوقتي أنا عندي two variables وأنا من الأول I'm assuming which one is the dependent and which one is the independent. And I want to test to what extent the increase in the independent will affect the dependent. So this is the question that I could answer based on the regression analysis. And I'm doing the regression analysis to explain the impact of the changes in the independent variable on the dependent variable.
سوري يا دكتور معلش، هو احنا ممكن بس نوقف الويت، نفتح الويت للكل عشان هو بيدي الارم بيفصل الصوت بتاع حضرتك.
مش انا اللي عندي
هي القصه يا فندم ان الدكتوره اللي عملت الانفيتيشن مش موجوده، فمش قادرين نعمل الغاء الويتنج. انا سوري فور ذس واعتذر بشده، حصل لها ظرف فهي مش موجوده، فبضطر ان انا اقبله واحد واحد. انا عارف ان هو يعني irritating بس غصب عننا، انا ما عنديش حل ليه. I'm not the host of the meeting today.
سوري اوكي شكرا.
تامر انا بعمل كل الناس اللي بشوفهم بدخلهم، فبتقلق انا مش عارفه هو عمل لي ادمن فعمال ادخل في الناس.
طب الله يكرمك، الشاشه ظهرت عندك دكتوره ايمان؟
انا لا مش ظاهره بس مش مشكله، انا سامعه الدكتوره ما فيش مشكله.
طب
بس انا
دكتوره
بقول
قمر
لك
معلش فضلا حضرتك الغي الشير واعمليه تاني.
اوكي حاضر.
هو انا كده
ممكن
عمال لي
دكتور
ادمن مش عارفه ازاي، فانا
كان
انت
بدخل
ازاي
update.
كل
ادمن يا
الناس.
ايمان؟ انت ازاي
ما اعرفش
اتعملتي ادمن فجأة كده؟
مش عارفه
ده هايل،
مش عارفه مش
ده
عارفه
هايل،
فعمال ادخل في الناس، كل شويه
هايلة،
تطلع لي
برافو
الشاشه
عليك.
مدخلاهم. بص الشاشه ظهرت.
كده ظهرت اهي، انا عندنا من الاول ظاهرة يعني.
طيب اتفضلي يا دكتوره، واسفين على المقاطعه.
مفيش
وانا
حاجة.
بعتذر مره اخرى على موضوع الويتنج دوت، انا مش في ايدي ان انا الغيه للاسف الشديد النهارده يعني.
طيب, back to the regression analysis. The question I want to answer from the regression analysis is to what extent the change in the independent variable will affect the dependent variable. وده معناه ايه؟ معناه ان before doing the regression analysis, I should assume which variable is the dependent and which variable is the independent. And not only this, it also explores the nature of the relation between the two variables. We have different forms of the regression analysis, and it all depends on two things. The first is the type of the dependent variable, and the second is the numbers of the independent variable. So, based on the dependent variable, whether it's continuous or dummy variable, I will choose the type of the regression. Let's start with the dependent variable when it's continuous variable. If I have the dependent variable as a continuous variable, like the systolic blood pressure, like the serum creatinine, like the cholesterol level, I will use the linear regression. So I have two big families of the regression. Honestly, there are three, but let's speak about the two most common, the linear regression and the logistic regression. The linear regression, I use it when the dependent variable is continuous variable. The logistic regression, I use it when the dependent variable is dummy variable or binary, is a binary variable. So yes or no. Starting with the simple linear regression analysis, let's take this example. Suppose that we collect data on two variables. The first is the waist to hip ratio, and the second is the cholesterol. And in all these scenarios, I will consider Y as the dependent and X is the independent. So here, what's the dependent is the cholesterol level. What's the type of this variable? It's a continuous variable, so the linear regression could fit. And this is my data. This is the ID for the different patients, and this is the cholesterol levels, and this is the waist to hip ratio. I want at first to fit a straight line that describes the linear relationship between X and Y, and put this in your mind, why I'm fitting this linear relationship, because we will mention this later. As long as I have one independent variable and the dependent variable is the Y, then the changes in Y are assumed to be caused by the changes in X. So usually the X or the independent variable is on the X axis and the dependent variable is on the Y axis. And this is the linear relationship between X and Y. Now I want to answer to what extent the change in the waist to hip ratio will change the cholesterol level. This is the question I want to answer. I did the analysis, and this is the different output I will get from the SPSS. What is important to report? The first thing I want to report is the R square, which is 0.015. So I have to look at the R square at the beginning. What does it mean? It means the amount of the variation in the dependent variable that could be explained by the independent variable. How much X explains the variation in Y. Let me take you back to the correlation analysis. Now I am doing a simple linear regression, which means that I'm testing the relationship between one independent variable and one dependent variable. So I'm testing to what extent the change in X in this scenario is the waist to hip ratio will affect the Y, which is the cholesterol level. At first, I can do the correlation. And based on the correlation, I will have the correlation coefficient. And second, I will do the linear regression. In this case, because I have only one independent variable, I am doing simple linear regression. And the first output I get from this is the R square. What's the R square? As I mentioned, it's the amount of the variation in the dependent variable that could be explained by the independent variable. The amount of variation in the cholesterol level that could be explained by the waist to hip, the change in the waist to hip ratio. If I do the correlation analysis and I get the correlation coefficient in this scenario because I have a simple linear regression, the square value of the correlation coefficient will be exactly the same of the R square. So I'm doing a correlation analysis. And in the correlation analysis, I consider only two variables in my analysis, the cholesterol level and the waist to hip ratio. And at the same time, I'm doing a simple linear regression. What I get from the correlation analysis is the correlation coefficient. And what I get at the first step from the output of the simple linear regression is the R square. In this scenario, because I am dealing with one-to-one variable, one independent versus one dependent, the R square is exactly the squared value of the correlation coefficient. And in both cases, what does it refer? It refers to the extent of the variation in the dependent variable that could be explained by the independent variable. So here I have the R square equals 0.015, which means that 1.5% of the variance of the cholesterol could be explained by the waist to hip ratio. 1.5 of the change in the cholesterol level I could explain by the change in the waist to hip ratio. And the same value I can get from the correlation analysis because here I am doing simple linear regression. What I need to look at after this? I have two things that I need to look at from the regression analysis. Something called the B node, which is the estimated average value of the Y, the estimated average value of the dependent variable when X equals 0. And the B1 is the estimated change in the average value of Y per 1 unit change in the value of X. What does it mean? I have two terms that I'm usually using in the linear regression in general, something called the intercept and something called something refers to the slope. What does it mean? The intercept is the value of Y, the value of the dependent when the independent equals 0. When the independent has no effect, what's the prediction of the Y? Someone will ask me, how can I predict something and I don't have a value for the X? It's estimated equation. It's not observed equation. So the software plays with the number to estimate the predictability of having the outcome. So in this case, what's the intercept? The intercept based on the output is the constant. To what extent I will have the predicted cholesterol level when the waist to hip ratio equals 0. So based on the equation, this is a linear equation. The predicted cholesterol when the waist to hip ratio equals 0 will be 171. This is the intercept or the constant. And what's the slope? The slope is the amount of the change in the predicted cholesterol when the waist to hip ratio increases by 1 unit. So when the waist to hip ratio increases by 1 unit, to what extent the cholesterol will increase? And in this case, I would like to look at three things actually. The unstandardized coefficient, which is here, and the confidence interval and the significance. Here the unstandardized coefficient refers to the slope. So per 1 unit increase in the waist to hip ratio, the predicted cholesterol will increase by 1.97. If I put here 1, then the predicted cholesterol when the waist to hip ratio equals 1 will be this plus this. Okay, so this is the intercept, which means the value of the predicted cholesterol when the independent variable in this case is the waist equals 0. And this is the slope, which means the predicted cholesterol when there is 1 unit change in the independent variable. In this case, it's the waist. So this is the most important thing that I need to look at. But what's next? I need to look at one of two things, either the confidence interval or the significance value. And one of them will reflect the other, but the other will not reflect the other. So the confidence interval will give me an idea about the significance, but it's not the opposite. What does it mean? What's the confidence interval here? The confidence interval ranges from 0.21 to 1.73. And here I'm dealing with a linear regression. So put in your mind is that it's a linear regression. In the linear regression, in this case, what's my hypothesis is I have the independent variable is the waist to hip ratio, and the dependent variable is the cholesterol. So when I can say that there is no linear relationship between the waist to hip ratio and the cholesterol, when I have the value of this correlation or this relation equals 0. So when I have the relationship between the waist to hip ratio and the cholesterol equals 0, it means that there is no linear relationship between the two variables. In this case, the 0 refers to what's called the neutral value. What's meaning that there is no relationship between the x and y. There is no relationship between the independent and the dependent variable. When I look at the confidence interval, if the 0 value, which is the neutral value, is not lying between the lower and upper limit, I will be definitely sure that this relationship is significant. So I don't want to look at the significance because I'm deadly sure that this relationship is significant when the confidence interval in the linear regression does not contain the 0 value in between the lower and upper limit. And the 0 value here, because it refers that there is no relationship between the x and y, the independent and the dependent. So the neutral value in the linear regression is the 0 value. 0 value refers to no relationship between x and y. And when the confidence interval does not contain the 0 value, which is the neutral value, it means that this relationship is definitely significant. So the B node, which is the intercept, it's the estimated average value of Y, which is the cholesterol level, when the X waist, the waist circumference equals 0. So it means that the average cholesterol increases by 171 milligram per deciliter when the waist circumference is 0. While the B1, which is the slope, tells us that the average value of cholesterol increases by 0.97 milligram per deciliter for each 1 centimeter increases in the waist circumference. So based on this equation, I can predict the value of the cholesterol when I change the value of the waist circumference. So for 1 waist circumference, the predicted cholesterol will be this plus this, while for 2 waist circumference, it will be this times 2 plus this value. As we mentioned that the significance refers to whether the waist to hip ratio is a significant predictor for the cholesterol or not. And as we mentioned, we can look at the confidence interval, and based on the confidence interval, I can predict or I can imply whether this relationship is significant or not. And in the linear regression, the neutral value is 0. So as long as the confidence interval does not contain the 0 value, I'm deadly sure that this relationship is a significant relationship, which means that the waist to hip ratio could predict the cholesterol level. Is that enough? It's definitely not enough, because we are human beings, so we are not testing the relationship between two variables. And that's why the simple linear regression, it's a theoretical regression, but it does not reflect the truth. Because if I want to predict the cholesterol level, I should put in my mind other variables or other determinants that could play a role in this relationship. The simplest thing is the age and sex. To what extent the cholesterol level will it change based on the waist to hip ratio, considering the change in the age and sex? That's why I need to jump to what's called the multiple linear regression analysis. So what's the multiple linear regression analysis? We have the following data sheet, and it contains details of 42 babies and their parents at birth. The dependent variable is the birth weight, and the independent variables on this sheet are the gestational age of the baby at birth in weeks, and the variables relating to the mother's height and mother's weight, as well as whether she is smoker or not. So the dependent variable in this scenario is the birth weight of the baby, and I have different independent variables. Looking at the gestational age, the smoking history of the mother age, the mother height, and the mother weight. And I want to understand to what extent these variables will affect the birth weight. At first, I can do the scatter plot to understand the relationship between the gestational age at birth and the birth weight, but I have here other third variables or other confounders that could play a role in this relationship. As an epidemiologist or as a methodologist, it's always preferable to start your statistical analysis by putting in your mind the research question you want to answer. So I want to answer in this scenario to what extent the gestational age will affect the birth weight of the baby. But I have other variables that could play a role in this relationship of interest. So what's the x-axis? The x variable here is the gestational age. And what's the y variable or the dependent variable is the birth weight of the baby. What are the third variables or the potential confounders? The smoking history of the mother, the age of the mother, the weight of the mother, the height of the mother. So I want to test the relationship of these all variables together to predict to what extent the gestational age will affect the weight of the baby. The multiple linear regression model, it's more or less the same like the simple linear regression, but I'm putting in my mind that I have more than one predictor variable. So I have x1, x2, and several forms of the different independent variables. And all these variables, I want to test its effect on the dependent variable. So it's also, I'm putting it in a linear equation model, but instead of the previous one is for the simple linear, it was y equals b node plus b1 times x1. I have here several b's, and the same, I have only one b node. How can I interpret the output of the multiple linear regression? Also, I will look at the R square, but here the R square will not refer to the correlation by any way, because here the R square refers to what extent the variation in the birth weight can be explained by the model containing all these variables together. So it's not one-to-one relationship. So here I have the R square equals 0.61, which indicates that 61% of the variation in the birth weight can be explained by the model containing the gestational age, the smoking, the pre-pregnancy weight, the pre-pregnancy height, and etc. Then what's important is also, as we mentioned before, the unstandardized coefficient and the confidence interval or the significance. So this is the equation. The birth weight, which is the dependent, will equal the constant minus 7.165 plus, this is for the gestational age, the slope for the gestational age times the gestation, and then I will have the slope for the smoking times the smoking, and then I will have this slope for the mother pre-pregnancy weight times the pregnancy weight. How can I interpret these values together in this equation? Let's start with the easiest one, which is the intercept. The intercept simply is the change in the birth weight when all other predictors equal 0. So the birth weight is decreasing because it's the sign here refers to whether it's increasing or decreasing. So the birth weight will decrease when all other variables equals 0. But this is not that important for me in the multiple linear regression because I want to understand to what extent the effect of the different variables on the outcome variable or in the dependent variable. So let's start with the gestational age. For the gestational age, there will be 0.31 increase in the birth weight for each extra week of gestation when other factors are fixed. So to interpret the unstandardized coefficient or the slope of different predictors in a multiple linear regression, I want to interpret it in terms of fixing the effect of the other variables. So to interpret this, I need to take in my mind the sign of this relationship and fixing the effect of the other variables. And that's what I mentioned here. There is increase by 0.31 in the birth weight for 1 week increase in the gestation when other variables are fixed. When I look at the mother weight, so the mother weight here, there is increase in the birth weight by 0.02 if the mother weight increased by 1 unit. So by 1 unit, by 1 extra pound increase in the mother weight, the baby's weight increases by 0.02 when also the other factors are fixed. While for the smoking is a binary variable. It's in the form of 0 and 1. And usually when I enter my variables in the model, I tell the model which of these categories please consider as a reference group. And usually I put the no or the non-smoking or the non-diseased or the lowest risk as a reference group. Here I have 0 refers to non-smoker and 1 refers to the smoker. So if the mother is a smoker, there is a decrease in the birth weight by 0.66, considering the other variables are fixed. So this is the way by which I can interpret the values of the slope of the multiple linear regression. And of course, I'm looking at the significance. And if I have in the model the confidence interval, I will look also at the confidence interval to see whether this relationship is a significant or not significant. This is in brief the story of the linear regression, but I need to put in my mind certain assumptions to be able to apply the linear regression analysis. At first, the linear regression, as we mentioned, it should be used when the dependent variable is a continuous variable. So we don't have we shouldn't violate this assumption. The second thing is the association between the dependent and independent variables must be linear. And the third is the residuals must be normally distributed. And this is a tricky point because some people consider the normality of the X and Y variables, while it's not that. And when you get reviewing from one of the reviewers for your manuscript, and you mentioned, did you test the assumptions for using the linear regression? You usually thought that the normality refers to the X and Y variables, while the normality refers to the residuals. And how can I calculate the residuals? I can calculate the residuals by the software. I can ask the software to save the residual of the relationship between X and Y, and then I will test the normality of these residuals. So the assumptions of the linear regression, for the normality, it refers to the normal distribution of the residual relationship between X and Y, and not the normal distribution of X or Y. This is an example of the saved residuals. This is the residuals. And then I test the normal distribution of these residuals. If it's normally distributed, then I can use the linear regression. Let's take an example from a clinical scenario. We have chronic kidney disease patients, and it's known that chronic kidney disease patients usually complain of malnutrition, and the malnutrition is related in a way or another to the thyroid function. I will take two biomarkers to assess the relationship between the malnutrition and the thyroid function among the chronic kidney disease patients. As a biomarker for the malnutrition, I will take the albumin, and as a biomarker for the thyroid function, I will take the free T3. At first, I will do the correlation analysis to investigate the degree of the correlation between the two continuous variables, how much a given relationship is fitted by a straight line. I have here the two variables, and then I fit this relationship, and I get this value of the correlation, which is R equals 0.52, and it's a significant correlation. But I have a data set, and in this data, I also found that the FT3 is inversely correlated with the age. So this is the clinical scenario. I want to test the relationship between the albumin and FT3, and I found that the two variables are correlated to each other. I want to test to what extent the increase in the plasma FT3 will increase the serum, to what extent the increase in the serum albumin will increase the FT3. So I did a simple linear regression. And this is what we mentioned, that the intercept refers to the value of the Y, or the dependent variable, which is the FT3 when the albumin equals 0. And the slope refers to what extent increase in the dependent variable per 1 unit increase in the independent variable. And here is the equation. This is the intercept. The value of the intercept is in negative, so there is a decrease when the albumin equals 0. The FT3 will equals minus 1.84, while per 1 unit increase in the albumin, the FT3 will increase by 1.36. So the relationship between the albumin and FT3, it's a direct and it's a positive relationship. As we mentioned that in this data set, we found also that there is a relationship between the FT3 and the age. And now we will introduce the multiple linear regression. To answer this question, is the association true or it may depend on other factors, which are the confounders. And to understand simply what's the confounder, as we mentioned, it's a third variable. And to refer to a variable that it's a confounder, it should fulfill certain criteria. The third variable should be associated with the independent variable, could lead to the dependent variable, and not in the intermediate relationship between the independent and dependent variable. So in this example, we have the age as a confounder. And to test the relationship, what's the relationship of interest here? The relationship of interest is the effect of the albumin increase on the FT3. But I want to test this relationship taking in consideration the age of the patients. So I will perform multiple linear regression, taking the age as a confounder, because the age fulfills the criteria of the confounder. It influences both the FT3 and the albumin, and it's not an effect of the albumin, which means it's not in the intermediate pathway between the independent and independent, and it's not leading to, it's not an outcome of the exposure. As we mentioned, how to interpret the B1 in the multiple linear regression. B1 is the average difference in the FT3 unit, in the FT3 per unit difference in the albumin for two individuals with the same age, or if the person age equals 1. Now I want to jump to another form of the regression, which is called the logistic regression. As we mentioned in the beginning, that we have two big families of the regression, either the linear regression or the logistic regression. For the linear regression, we use it when the dependent variable is a continuous variable, while the logistic regression is used when the dependent variable is binary variable. So we have here an example for the coronary heart disease, and we want to predict, or we want to study the influence of the age, gender, and the smoking on the coronary heart disease. Our question could be, what's the mean increase of the probability of having coronary disease for each 10 years increase of the age? And I want to test the relationship of the age and its effect on the coronary heart disease, taking on consideration the effect of the gender and the effect of the smoking. And this is our data. So we have the age, we have the gender, we have the smoker status, and the disease. 1 refers to whether he is a diseased, and 0 refers that he is not diseased. So as long as the dependent variable is a dummy variable, I cannot use the linear regression. Why I cannot use the linear regression? Let's assume that this is the visual expression of our data. So the coronary disease is either yes or no. And regardless of what we have on the x-axis, the data will be collected in this way, in between the no and the yes. If I try to fit a linear line, I will not be able to fit this line because I will not be able to consider all these readings. So the linear relationship is not adequate in this case. And I have to jump to other form of expressing the relationship. And this is what's called logistic function. Without going in details on how to calculate the logistic, the equation for the logistic function, I'm taking in my consideration when I develop the logistic regression, the best way to express the relation between the x and y, taking in my consideration that the y is the probability of having the disease. So this is the best way to express this relationship, and we can see it's not a linear relationship. So the probability of the dependent variable is given by this equation for a given value of the independent variable. This is the equation of calculating the logistic regression. And when I'm putting this in my consideration, I'm testing the probability of having the disease considering the different independent variables. So to interpret the output, at first I will look at the significance of the model. And here, this refers to that this model is significant. This significant refers to what? Refers to building a model without any independent variable and combining this model with another model that contains the independent variable. So the first model is considering only the probability of having chronic kidney disease, coronary heart disease without considering any independent variable. And the other model is considering the different independent variables. To what extent the second model or the model considers the independent variable will add a value to the model 0. Here it's significant, which means that this model with the independent variable is significantly different from the model without the independent variables. So this is the first to look at when looking at the output for the logistic regression. And second, I'm looking at the overall percentage, this one, and it refers to that this model with these independent variables I entered in this model could explain 72% of the variation in the dependent variable. So the model that contains the age, the gender, the smoking history could explain 72% of the variation of having a coronary heart disease. And the third and the most important of the output is this table. I want to answer to what extent the increase in the independent variable will increase the probability of having the disease. So the output, the dependent variable here is yes or no, whether to have the disease or whether not to have the disease. The probability, to what extent this probability will increase. This is what I get from the data I presented now. And here I have the 3 variables I introduced in the model, the age, gender, and smoking. To look at this output, I need to look at the B, the exponential B, the confidence interval, and the significance. Let's start with the exponential B. The exponential B refers to the probability, the odds of having coronary heart disease when the age increases by 1 unit. So to what extent increasing the age by 1 year will increase the probability of being in the category of coronary heart disease or of having coronary heart disease. Here it's equal 1.044. Okay, that's good, but does it a real value or does it a significant, does it refer to a significant value? I can answer this question by looking at the confidence interval. But here, the neutral value for the logistic regression analysis will be 1, because 1 here refers to that I don't have any probability to get the disease. 1 refers to that increasing the age will not increase the risk of having coronary heart disease. So for the logistic regression, the neutral value equals 1, which means that if the confidence interval includes the 1 in between the lower and the upper limit, that means that this relationship is not significant. And this is reflected on the p-value here. the p-value is 0.09 because the value of the lower confidence interval 0.99 and the upper value is 1.09, and so the neutral value, which is the one, is in between the lower and the upper value. The same goes for the gender. What's the exponential, the odds ratio here is 2.38, and this is a very great value, but if I look at the confidence interval, I will find it ranges from 0.49 to 11, which means that the one value, the neutral value in between, and that's why this relationship is not significant. And then when I look at the smoking, I will find that the exponential b or the odds ratio equals 3.8, and also the confidence interval ranges from 0.8 to 17, so the neutral value is in between, and that's why this relationship is not significant. So at first I'm looking at the exponential b, and then I'm looking at the confidence interval, which gives me an idea about the significance. What's this referring to? This is referring to the direction of the relationship. What does it mean? It means that if it's positive, if the values are positive, this means that this relationship is positive relation, which means that an increase in the age will increase the probability of having the disease. If this relationship is negative, it means that this relationship is reversed. So the increase in the independent variable will decrease the probability of having the disease. As long as this output is not significant, I try to put a hypothetical output from my data, and here we can look at the exponential b is 1.10, and the odds this is the odds ratio, and the confidence interval ranges from 1.05 to 1.21, so the neutral value is not included in between the lower and the upper, which means that this relationship is significant, and the b is positive, so this relationship is positive relationship. How can I interpret this value? Per 1 unit increase in the age, the probability of having coronary heart disease will increase by 1.10. The same for the gender. The odds ratio is 2.38, and the confidence interval does not include the neutral value in between, and the beta, yes, is positive. So here I should tell the software when I'm doing the analysis which group is the reference group. Here I assume that the female is the reference group. So how can I interpret this relationship? If this patient is male, his probability of having coronary heart disease will increase by 2.39 compared to the females. Now, what are the take-home messages from this presentation? At first, the first question, could we compare between correlation coefficients with different ranges? What does it mean? Could I compare the correlation coefficient of the relationship between the body mass index in the range of 10 to 20 kilogram per meter square and the abdominal circumference, and the body mass index in the range of 20 to 25 and the abdominal circumference? No, I cannot compare the correlation coefficients unless I have the same range of the data. The second, could we do correlation for non-normally distributed data? No, because I should consider the outliers when doing the correlation, as it will distort the relationship. I can do some forms of the correlation like the Spearman and the other types of the relationship. But the simplest or the most classical type of the correlation, the Pearson correlation, I cannot do it when I have outliers. How many covariates can be included in the regression analysis? As a rule of thumb, I should include 1 covariate for every 10 events. So if I have 10 covariates, I should have 100 individuals with the study outcome. How to choose among the included variables? The variables which are significant in the univariate analysis are always included in the model, considering that they are not interrelated. These are examples from the literature. The first paper refers to the title is The Underlying Factors Associated with Anemia in Amazonian Children, and this is a population-based cross-sectional study. And this study wanted to estimate the relative contribution of the different factors to anemia, and they did a multiple linear regression, and this is the output. They included these variables, and the outcome variable or the dependent variable was the hemoglobin. Looking at the outcome, at first, we found that the age is significant. All of them are significant, honestly. And how can I interpret these values? Per 1 month increase in the age, the hemoglobin level will increase by 0.10 when other variables are fixed. When we look at the wealth index, per 1 unit increase in the wealth index, the hemoglobin level will increase by 0.24 when the other variables are fixed. This is with a negative relation, it's a negative. So per 1 unit increase in this variable, the hemoglobin will decrease by 1.20 or 21. And the same goes for the C-reactive protein. Per 1 unit increase in the C-reactive protein, the hemoglobin level will decrease by this value. And this is an example for the logistic regression. And this paper, they wanted to test the prevalence on risk factors for the chronic kidney disease and diabetic kidney disease among the Chinese urban population. And they did cross-sectional survey. The outcome was diabetic kidney disease, and they tested the effect or the relationship between the different predictors and to develop or not to develop kidney disease. And these are the odds ratio. Here they didn't refer to the p-value because in some authors consider reporting the confidence interval is much more important than the p-value, as long as you know that for odds ratio, the neutral value is 1. So as long as the confidence interval does not contain the neutral value, this relationship will be definitely significant. So let's take an example to interpret here. Looking at the gender, here the woman is the reference group and the men are the group to be tested. So the men have a higher risk of getting diabetic kidney disease by 1.85 compared to the women. So before I finish, I need to answer the 2 points we referred to at the beginning of our presentation, the prediction and the regression, and the causation and the other terms we used. Let's start with the prediction and the regression. From a statistical point of view, we can use both terms interchangeably because in the regression analysis, we try to predict the value of the dependent variable based on the independent variables. For us as methodologists, we don't like to use the word prediction unless we are doing a follow-up study, a study that takes in its consideration a time factor, because I'm looking to the future. So it's not just the statistics that tell me the future. I need the study, the time frame to be a follow-up study. So it depends on your preference. But as an epidemiologist, I usually prefer to use the term prediction when I'm doing a follow-up or a cohort study and not just when doing the regression analysis. This is the first point. The second point, the correlation and causation. As we mentioned, correlation does not imply causation because the term causation takes in its consideration other characteristics that should be included in the study and not only the statistical analysis. At first, the study design, and I think that most of you know the hierarchy of the study designs. that when the study is in the highest level of giving the evidence based, it's usually closer to the evidence of the causation, the dose response relationship, the temporal relationship, and the direction of the relationship, and the biological plausibility. And we refer to this criteria as Bradford-Hills criteria. So the term causation is not to be used based on statistical analysis. It's a broader term, and I cannot use it unless I fulfill the other criteria or the Bradford-Hills criteria. And thank you.
شكرا جزيلا دكتورة سمر، يعني محاضرة كانت دسمة، وأنا عايز أقول لك إن إحنا بدأنا بحوالي 100 حاجة و20، مستمر معانا لحد دلوقتي 104، من إحنا خدنا تلت الساعة زيادة. أشكرك مرة أخرى. هنفتح باب الأسئلة، يعني هنبدأ بالأستاذ الدكتور صلاح مصطفى، أستاذ الأجيال، الأستاذ العظيم وأشكره على وجوده معانا. اتفضل دكتور صلاح. دكتور صلاح حضرتك اعمل انميوت علشان نسمع صوت حضرتك.
هو تقريبا
يعني
اتفضل يا دكتور صلاح.
تمام اتفضل.
وانا بشكر استاذ الدكتور تامر على المجهود اللي اتعمل. ده حلم كنت بحلم بيه، شفته بره في كل الجامعات، اشتغلت في 4 جامعات في امريكا، وحاولت في جمعيه طب المجتمع، بكل اسف ما امكنش. دكتور تامر عمل الكونتينيو ميديكال اديوكيشن، مجهود رائع منه من الزملاء، والعرض رائع. بس انا ليا تعليق يمكن بس عشان واحد عجوز شويه، وعملت كذا شغل. الدكتوره سمر قالت موضوع الكوزاليتي، او الكوزاليتي ده ليه كريتيريا سيادتك قلتيها. انا بس في حته عايز بس نور عليها، حكايه الار او الار والسيجنيفيكانت. الار بتقيس العلاقه الاسوشيشن، يعني كل ما كان زيرو ما فيش علاقه، كل ما كان مثلا، وده سيما زي حضرتك قلتيها، بيبقى مبدئي مثلا 0.5 علاقه ضعيفه، 0.25 او اقل من 0.5 لحد 0.7 مودريت، واكثر من 7.75. دي تقسيمه كريتيريا زي ما انت عايز. البي فاليو السيجنيفيكانت بتاعها، الثقه. يعني انا اشتغلت في المجمع ستادي، كان القلب من علاقته مع الكورونري حوالي 0.2، لكن سيجنيفيكانت. يعني كل ما اكل لحمه زياده او لحوم بروتين زياده بمعنى اخر هيأثر، مش زي الكوليسترول. الكوليسترول علاقته كان في المجمع ستادي حوالي 0.9. فكان الداتا هي طبعا فكره كلها الايفيدنس ميديسن اللي ابتدوا يتكلموا عليها. عندي ادله، مش انا بقول، ما فيش حاجه اسمها واحد بيقول، لكن الادله، والدكتوره مشكوره جابت نماذج رائعه. بس انا كان نفسي برضه حته الار، المالتيبل ار او ار سكوير. الار انا دلوقتي مدخل عندي الموديل فيه 10 متغيرات اندبندنت. هل الكورونا بيحصل من الكوليسترول بس، ولا بيحصل من السن، بيحصل من الهرمون؟ في ناس عندهم جالهم كورونا وهم عمرهم طبعا سين جينيتكس، فهي مالتي فاكتوريال فاكتور، مش واحد. مثل المالتيبل ريجريشن، انا اسف وانا سعيد جدا ان قدمتها بطريقه رائعه، ان انا بيبقى عندي اكتر من اندبندنت فاريبل، المالتيبل بتجيب لك على بعضهم كلهم. انا عايز بس تجربه شخصيه مش علميه طبعا. لما رحت المؤتمر في اليابان، كل الدكاتره اليابانيين اللي في سني كانوا قصيرين، كل الدكاتره الشباب زي سيادتكم بقوا طوال. طبعا واضح في جينيتك وفي تغذيه وفي حاجات كتير اتاثرت. انا زمان كنت بصلي في الجامعه كنت طويل، دلوقتي بقيت قصير. لاحظوا اغلبنا دلوقتي في فرق واضح. فهي كل حياتنا زي ما الدكتوره قالت في مالتي فاكتوريال، مش فاكتور واحد. السن والوراثه والاكل والشرب والراديشن والاكسبوجر طبعا في، انا اذكر كان في ندوه في لازر، فمره زميله لينا بتسالني، كنت مقدمها، فبتقول لي، بتسالني في المعادله ازاي؟ قلت لها انا ما اعرفش اعملها، احنا مسؤول عربيه، انا مالي من الميكانيكا بتاعتها. اللي بيعمل المعادلات دي زمايلنا في العلوم والرياضه البحته بيعملوا المعادله، والشركه بتاخد المعادله دي وتعملها احنا بنطبقها بس. انا سعيد جدا جدا وبشكر الدكتور تامر والزملاء كلهم. انا يعني عملت حلم انا كنت بتمناه، مش عشان انا جيلي، انا في اخر السبعينات، في الاجيال الجديده ان شاء الله. شكرا دكتور تامر والزملاء كلهم على المجهود الرائع، وان شاء الله حاجه مستمره، وبشكره. بس انا حبيت اوضح بس المالتيبل الار سكوير مهم قوي، البيتا كمان. البيتا زي ما الدكتوره سامر قالت بتفسر تاثير كل واحد في وجود الاخرين. يعني الوراثه بتاثر، لكن الوراثه مع عوامل تانية بتاثر يعني. فهي موديل رياضي عملوه مش احنا، عملوه زمايلنا في كليه العلوم، بنشكرهم على المجهود. شكرا دكتور تامر والزملاء كلهم، شكرا جزيلا.
ميرسي لحضرتك يا دكتور صلاح، اتشرفنا بحضرتك.
شكرا يا دكتور صلاح. اتفضلي يا دكتوره منال.
لا انا كنت هقول في دكتوره، انا بشكر طبعا حضرتك الاول يا دكتوره سمر، يعني بصراحه excellent presentation، استفدنا جامد جدا. شكرا على المعلومات وطريقه العرض اكثر من رائعه، شكرا جزيلا. هو في دلوقتي كمان دكتوره سالي زينه، اتفضلي في سؤال.
السلام عليكم.
وعليكم السلام ورحمة الله
ازيك
وبركاته.
يا دكتورة سمر، عاملة ايه؟ يا
الحمد
رب
لله.
خير. بسأل بس حضرتك دكتورة سمر، دلوقتي في جداول في اللينير ريجريشن، يعني بدأت أشوفها وأركز فيها. هي دلوقتي بتبقى مثلا في يوني فاريت ومالتي فاريت. هل اليوني فاريت دي اللي كان مقصود بيها في كلام حضرتك السمبل ريجريشن؟
اه
والمالتي